afternoon. Can you hear me? Anyone, please?
Yes, sir.
Oh, last class we were talking about how to measure the wind power. No, connection with that. Why it is important? How do we measure wind speed and other parameters? Wind direction, temperature, humidity, those things. Other than those, so calculate like the air factor, the balance production, the wind power, power law, and depth, etc. We can calculate from there. Basic wind data because because like if we are planning for no wind farming or suppose we are planning to give the PPGDT to the persons. That time, uh, that time this data, not only data but analyzed data, it's playing an important role because as much as the accurate we are getting from the source analysis, then will be calculate a and prediction. I mean, uh, in between theory and experience, there will be lesser difference or error. It will be there. So, for the prediction of profit and losses, they can calculate it easily. That informed person. So that's why it is important. Here I'm sharing one Excel sheet where to fill up this one with your knowledge on softwares or coding or some programming languages. So accordingly, we can provide you the topics. So you'll get the notification in your mail regarding this. I mean the details of Excel sheet you'll get. If it is not opening, then one more thing. Removing the previous one, the latest one will be sharing.
Excuse me, sir. Sir,
Yes.
so actually your voice is breaking.
Share net is disturbing during class time. Too many users are there now in a single network. I mean, as we
Okay,
are
sir.
using LAN, institute LAN, nowadays is disturbing for last 1 week. Don't know. It may be due to busy of that LAN connection. So this is the link. This is the link there in the chat box. By using this link, you can you can access the Excel spreadsheet. So check it once. Can you access it? Have you tried?
No, sir,
With
it's
this link?
showing you need access.
Now check it once. I can just check it.
Yes, sir.
It
Yes, sir.
will
Now it's
work.
opening.
So they are in the column D. In the column D, you have to fill up. Like who is accessing now roll number 9. Isn't it? Donush? Or roll number 1. You just fill up it. So later also you can do it. No? So we are talking about the basic parameters from the that meteorological mast. From here we are getting this basic data: the wind speed, wind direction. Just a minute. Yes. So we are talking about the basic parameters from the meteorological mast. So there we are getting the wind speed, and that wind speed will be collecting from the different heights, some standard heights. No, not only from one height. So some standard heights are kind of like 30 meter, 10 meter onwards, 10, 30, 50, 80, 100 from the ground level, okay, or above ground level, AGL, that is known as. And the wind direction also, we are the wind direction also, for the wind direction also, we are measuring from the same height.
Excuse me, sir. Sir, your screen is not visible.
Screen I have shown. Cannot see anyone? Anyone?
Yes, sir.
From
It's
side?
just showing that you are starting to share content, but it's not visible.
But I can see it is how we are like sharing this.
Yes, sir. You can try for
I
just stop it
show
and
you
start it
again.
once again. I guess it will
Correct.
be okay then.
Hmm. Hmm. Now, can you see? Can you see the
Yes, sir.
screen
Now
now?
it's visible.
Anyone? Okay. Uh, so there are some standard heights like um, 10 meter, 30 meter, 50 meter, 80, 100, even 120 from the ground level. Or in short, we are saying this one AGL, above ground level. So for the wind direction also, we have to mount the wind vanes at the same height. That is 10 meter, 30 meter, 50 meter, 80, 100. And there at least at the two heights, we have to mount the that wind vane and anemometer for wind speed and for the wind direction. This way, people commonly measure the wind speed and wind direction. And for temperature, pressure, and the solar radiation and humidity, it's not mandatory to like to mount at different heights, and even not even 10 meter from the ground level also. Okay, so for temperature, it's fine if you mount the temperature sensor 3 meter from the ground level or the half height. There should 3 meter from the ground level, and another one it will be the at the same height of the half. Half, you know, no, the wind turbine half where all the blades are not connected. That height we are known as half height. There, and another one is from uh, another one is 30 meter from 3 meter from the ground level. Okay, and for the pressure, it will be some close height to the that wind turbine or wind turbine hub. And for the solar radiation and humidity, it will be 3 meter from the ground level. So those are some standards. And here, by using some like softwares or some codings, suppose MATLAB or Python, there you can find the average wind speed in a short time, or the standard deviation, the maximum and minimum wind speeds for the entire like year or for 2 years. Here, one thing is important that like the wind speed for 10 minutes, at least not 10 minutes interval we have to measure. 10 minutes interval in speed. Okay? For each 10 minutes, we have to have the data set. Then, and at least for 2 years, we have to have the data set. Okay? So then turbulent intensity, the energy pattern factor, the air density, what we are deriving from the temperature and pressure, then the wind power density, like how much wind energy or wind power can be generated from 1 square meter area, and the power law index, and the energy pattern factor is the like how much yearly we can generate the power, and like turbulent intensity at different height. What is the changes of wind speed? As you know, the wind speed is more if you go above from the ground level. So suppose at 10 meter height from the ground level, suppose the wind speed is 5 meter per second. So at 30 meter height from the ground level, there is chances to be more than what we are getting at the 10 meter height from the ground level. And that is the turbulent intensity. So if you draw some graph, like it is the height, suppose it is the height and it is the then if it is the wind speed in meter per second. Okay, just have to. So here it is the height and it is the wind speed. Speed per second. So suppose this graph is something this way, and perpendicular line, okay. So it is suppose 5 meters per second, 5, 10, 10, 15, and for height suppose it is 10 meter height, then 30 meter height. So suppose it is 80 meter height. Then what is the variation according to height from the ground level? So this is known as the turbulent intensity. And there, and the wind speed distribution also we have to measure. Wind speed distribution is nothing but what is the average wind speed for suppose seasonal basis or annual basis, monthly basis. In the month of June, what is the average wind speed? Or in any particular week, what is the wind speed? It is known as wind speed distribution. Okay, and that one, the mean wind speed. Okay, about the mean wind speed. The mean wind speed is showing only the head wind speed. That is, it's not talking about at what height the wind speed is. Okay? So suppose in the news, if they are saying the wind speed is 20 meters per second, they are not mentioning the height. At what height the 20-meter wind speed is. 20 meters per second wind speed is. They are not mentioning. It is known as the mean wind speed at the head level, no average head level. So these parameters we must know. Later on, we'll describe this one in detail. Okay, intensity or what is wind shear or power law index, those. Then for wind resource assessment. So we are collecting the wind data, which is useful for the wind power project. Okay. Suppose we are planning some wind farm over there. So before that, we have to collect the wind speeds and the related wind speed data, including the pressure, temperature, humidity, the radiation, it is the solar radiation, everything we must calculate. And that wind speed at at different heights. And that one, if the wind speed is that much, like 20 meters per second, then for how long it may continue? So it's not like that for entire year we'll get 20 meters per second wind speed. So here you can see in monsoon season from April to September, we'll be getting some strong wind, some strong wind speed we are getting. And from May to September, so in the southwest monsoon or in the southwest, the monsoon wind speed we are getting. So it is good also. Then the wind speed during November to March, it is little low. No, November to March, it is little low. So there, the best wind speed we are getting in like South India region, mainly they are in Kerala, Karnataka, and Tamil Nadu area. Okay, and other than this, in Gujarat also we are getting some good wind speed, and in Andhra Pradesh also in South India, and in some central region like in MP and this Maharashtra, we are getting some good wind speed. From here we can generate the wind energy or wind power. Okay. Wind power we can generate. Wind energy is something else. For how long we are getting the power, that is known as the wind energy, or how much power we are consuming for any particular time. So that is known as the energy. You know very good that one. So these things are important. Here, you know which one is anemometer, that one the wind vane. No. So another type of wind vane which is coupled with this directly with this wind anemometer and the temperature sensor, pressure sensor. We have to mount everything there in the meteorological mast. Then in the data logger, the data will be logged. From there we can access the data manually or through some remote access also. You need not go to it is not required to go to in the location to collect the data. So remotely you can access those data. So here what we are discussing about the ultrasonic or sonic anemometer. So from this antenna, it will be sending the frequency. Okay. Then it will send it back to here. And to complete this cycle, how much it takes time. So from there we can measure the wind speed. This sonic anemometer, so it is giving the more accurate wind speed than mechanical anemometer. Because there are some rotating parts. It get jump, then rotational speed it will be reduced. So this is fine also. This is fine also. And other than this, gives the better result as there is no moving part. So here potentials are there in India. No, I must tell you, in the website, if you go through this no wind potential in India, it is from the meteorological mast. It will get some data, some data, satellite data. I'll show you the website, the upcoming slides. If you search there and you put your location which you are going to find out the wind speed, there they will show you the wind speed and the wind power density also, the parameters also are other data. So all the time that satellite data are not giving the most accurate result, but we'll get some idea. So there are no this is the estimated and some potential. So in Andaman and in Andhra Pradesh, that is for entire country, we are having the data, natural wind data or some measured wind data. So measured means we use that meteorological mast after mounting the different equipments, wind measuring equipment. It is known as the measured wind data. If we take the satellite by using the satellite data by that NASA or that is DTU, Denmark Technological University. So they are having satellite also. They are the owner of that satellite data. So from there we can check the wind speeds or other wind parameters. So here you can see the suitable features to have grouped into mainly three ranks: the rank 1, rank 2, and rank 3. this is the land, then the cultivation land and the forest land. The rank 3, the forest land, and it is the cultivation area. It is known as the rank 2. It's coming under the rank 2, and the weightage there. So weightage is 80%, 30% for rank 2, and 5% for the rank 3. So 5% wind energy we can generate from the rank 3 category. 80% we can generate from the wet land. So it is the some standard estimation. So here you can see in Andaman, for example, in Andaman, like out of total 8, so there are no percent. 50% west lands are there. No, the cultivation lands are 3%, and 1% is coming under this rank 3 category. And so they have divided this one into total 3 ranks. So these are the general informations, and this is the wind power generation requires in our country. So here the total installation, this color shows the total installation, the potential, how much wind power can be generated in this particular state, so Tamil Nadu and in Gujarat, how much wind power can be generated. So it is in megawatt, okay? It is in megawatt. So there is a huge potential. So here in Tamil Nadu, you just see. So like almost only 25%, 1/4 from the 1/4 area, or from the 1/4 potential area, we are able to produce the wind power till date. And another 3/4 areas are there. 3/4 area potential areas are there. From here we can generate the wind energy in Gujarat also. So much potential are there. Maharashtra, in other states also. So there is a huge potential in our country to generate wind power. And even you can check some magazines for this wind energy and solar energy, and from there some short question may come, like from the latest magazine, like suppose 2021 magazine. I'm asking 1 or 2 questions for 1 or 2 marks. So it's better to go with some latest magazines. So it will give you the update also, no? What is going on there in our country in renewable energy sector. So you can update yourself. These are some standard height. So here, what it is saying here, the measurement height should be half height. Okay, half height, So of the proposed wind turbine generator. WTG is nothing but the wind turbine generator. So it should be at the half height of the proposed wind turbine generator, or at least 2/3 of the half height. At least 2/3 of the half height. Suppose we were planning that wind turbine setup at the height of 100 meter. Half height. We are talking about the half height only. So if it is the stand, it is the turbine stand, and it is up for the blade, suppose. So till here we are measuring the height. Suppose here at the 100 meter we are planning to set up the wind turbine. So for at least 60 at the height of 66.66, we have to mount the that anemometer or the wind vanes. And other at the half height, we have to measure the mount the temperature sensor also. The temperature sensor. For solar radiation and humidity is not mandatory to set up over there, the half height or there. And if there are some terrains, suppose the location where you are planning to mount the single one wind turbine. In our college premises, we are planning to set up wind turbine. And if there is some terrain, means if there is some building or some trees are there, at that time the one anemometer, it must be above the terrain. Okay, above the height of that terrain. Okay, at the same height we are talking about, not top of the building or not top of the tree, but at the similar height we are talking about. So just above the tree height, we mount one anemometer, okay, and the wind vane, temperature sensor and pressure sensor. Then another height, we have to maintain some standard, either 30 meter, 10 meter, 50 meter, those height we have to maintain. So this standard we have to follow. Okay. So can you listen me? So can you hear me? Hello. Am I audible to you?
Yes, sir, you're audible.
Sir, hear you.
Please sometime you just respond, someone of you, like at least
Yes,
5
sir, but
minutes
the
interval
slides are,
or 2 minutes
the
interval.
presentation and your voice are not in sync.
Voice is breaking.
No, no, voice is clear, sir, but voice is little bit clear, but the presentation and your explanation is not in sync. Like the slide appears later and
Matching.
you have already. Yes, sir.
Hurry. It's not matching. So it is the drawback of online class.
Yes, sir.
Nowadays that internet is a little slow. No, and in few days we'll be getting the fiber optics connection in this week, in the end of this week. So in the next week onwards, we'll get some good network.
Okay, sir. Sir, if possible, please send today's class recording.
Recording, I don't know that recording is progress, but no, this PPT recording is not getting done. This PPT is not recording. The recording, your attendance and other attendance only recorded. Video, I had checked so many times. It is not getting. I can share you the slide. Share you the slide is fine also.
Okay, sir.
So here this standard we have to follow. So other than this, we are having that some IEC standard also. Yeah. Accordingly, we have to design any wind farm or that wind turbine blades. And like in wind farm project, so many steps are there. 8 to 10 steps are there, like feasibility, prospecting, then we'll go for wind resource assessment, then we'll go for some siting permissions from the landowner, then some financing, the financial part, then the engineer procurement. In engineer procurement, some analysis it will be there, like we have to do with some like analysis by CFD or others softwares. then constructions, installation, those parameters are there. Okay. Or in the feasibility or in the prospective stage, you have to discuss with the local community. Then you have to do some interview with the representative. Then you have to get some fair view of weather conditions over there. So, so those things are there. So it's a time-taking procedure for the setup of that wind farm. But if you plan for like individual wind turbines, it may be some small wind turbines, then you can do easily in a short duration of time. So here you can see another standard. So, like this is the distance what you have to maintain, and that is the like 7D distance. Okay, 7 times of diameter of this distance. That distance only we can mount the anemometer and wind vanes. Okay, and here also you have to maintain some 30 centimeter distance. Okay, this height. And here also there at the top of what you can see the anemometer. There you have to maintain some another standard distance. 1.5 meter. And lightning protection device, lightning protection rod you are using over here. Obviously, you have to use it. Then 60-degree inclination angle, we have to maintain. No, 60-degree inclination angle means the height we are talking about. From here, you measure 60 degree, then where is this coming? Then the height you have to maintain like a 7 into the diameter. Then it will work properly. The some distance as a height of lower anemometer, so 10, 20, 30. So that standard distance we have to maintain. Okay. So here, if you talk about the data analysis, so it is the process of evaluation the data using analytical, logical, and reasoning to examine each component of the data what we are having. And this form of analysis is just one of the many steps that must be completed when conducting a research experiment. Then the data from various sources has to be gathered, reviewed, and then analyzed. Data mining, intelligence, data visualization. So those things are there. So we have to go step by steps. Then here that data it may be measured, modeled, then compiled from both measured and modeled data, and they have that temporal some spatial components, and with that wind resource data can have a high degree of spatial variability, which emphasizes the need of high spatial resolution data. So that data can be represent wind speed and wind direction at different heights of the ground or from the ground, which is known as the how height. So this standard we can follow. Then is the sample of wind data. So this is the time. in 10 minutes interval. Let's say 10 minutes. Oh, okay. So 10 minutes interval, or it may be 1 hour interval also, but we prefer that 10 minutes interval data. Is the date, the past one is the date. So it's 1 hour interval data over here. Then temperature at 2 meter height with the temperature range. The pressure, the vapor pressure, 2 meter height or at the belows. Then the humidity at 2 meter height. The wind speed starts from here. The wind speed starts for 10 meter height for 30, 50, 80, 100 in the wind direction, and the height of 10 meter and 100 meter for minimum and maximum. So it's the sample only, okay? It's the sample only. So it's for like 1 day data. But if you take 10 minutes interval, so it will be huge number for 1 day itself. Then you have to collect the data for 2 years. 10 minutes interval you have to maintain. So those data are provided by the National Institute of Wind Energy or that NASA also. We have to purchase, we have to procure that. So this way we proceed for the wind data analysis. So there the website is. So you type this global wind atlas there in the browser. Then this one you can see here. You can type location and any other location also you can type. Then here this site will get the wind power density from the 1 meter square area, how much energy can be produced. Then what is the wind speed for the wind speed over there. Okay. Then this is known as the windrows diagram. Okay. So the dominating wind speed zone. So here you can see this is the dominated wind speed zone. Here in this direction, the wind is blowing more. So here you can click on the height. Okay, at different height you can click. So accordingly it will give you. So suppose 100 meter height has been clicked over there. So it is showing for the 100 meter height from the ground level. The ground level data. Above 100 meter above ground level data. So here you can click there the mean speed or mean power density, terrain. It is you can filter it. No? This way you can check the wind data from the website. Global Wind Atlas website. Fine. So here this is the Wind Atlas data. That means this red color means the most wind speed zone. Here this one. Here Kerala. That is this. This is the Kerala, Tamil Nadu side. And here in the Gujarat and in Ladakh, in more Kashmir zone, so their wind speeds are more. So season wise, you can check it also. So this way, you can check the different wind speed for different locations. Can you take the attendance? Yes.
Yes, I took it.
Yes, Intelligent. You have taken already? Have you taken?
Sir.
You have to
Yes, sir. I took it 10 minutes earlier.
take. So that's fine. If you are in the line, don't leave the class. So all the students, please type this one. And other than this, also like software, we are asking, program, we are asking if you know other than those. So you can type over here the relevant one, okay, like ANSYS Fluent or CFD or MATLAB, Python. So those languages or platforms, if you know, then please mention it. Right. Okay. After class, you can proceed for this clear part. So rule number 1, you know AutoCAD. Number 4, Python, SolidWorks, AutoCAD. MATLAB, who is working on rule number 35. You're working on MATLAB, rule number 37. So anyone working with data analysis, here anyone who's work already data analysis. I have that solar data and wind data for 2 years. So if someone is interested for data analysis, then you can do that one also for your mini. So okay then. Thank you all. You can leave the meeting.